So we're on the second half of A76, and we are looking at now multiplying equations. So now we have more than one fraction. We are multiplying two. The good news about this is it's all multiplication. So anything, any top to any bottom can cancel. So some people might want to put it all together and then cancel. I would like to cancel the pieces maybe. And so I'm looking that the 2 goes into 2 once and 2 goes into 8 4 times. That's called cross canceling. Any other numbers that could cancel here? Okay, 15 and 3 both divide by 1. 15. So number-wise, what's left in my numerator? 5 times 1 times 5, which is 5. And what's left in my denominator? 1 times 4. Now, I do want to clean up all the variables. So I have an x to the 4th times y to the 5th times x to the 2nd. How many total x's are in the numerator? 4, 5, 6. So x to the 6. And I still have that y to the 5th. All right, in my denominator, how many total x's are there?
5.
X to the 5th. So when you multiply bases, you're adding up the powers, y to the 2nd.
I understand.
Okay, so we've already got our number narrowed down to 5 over 4. We double check that we can't reduce more. We want to keep the fraction, no mixed numbers, no decimals. Who has more of the x's, top or bottom?
Top.
Okay, so I'm going to take out 5, and there's one left where?
At the top.
In the top. So just an x. Who has more y's, top or bottom? Bottom. So knock out, top has more, knock out 2 in the bottom. What's left in the top?
3.
Y to the 3rd. So we build our fraction to keep the pieces where they belong. All right, now, what's different about example A and example B? In example A, you had all multiplication, so we could jump in and cancel. In example B, you can't cancel the 4 here and the 4 here because it's addition and subtraction. You can't cancel the 2 and the 12 because you can't take it from all the terms. So we need to factor. So we have 4 things to look at. Does the x plus 2 factor? No, just leave it as x plus 2. Does the denominator factor?
Yeah, no.
GCF. What do they both divide by?
3.
All right, don't lose that 3. Divide both by 3, and we're left with x plus 4. Still times in the middle. Does this numerator factor? Nope, so keep the x plus 4. Does this denominator factor?
Yes.
Okay, there's no GCF, but see the first and the last term? What's the middle term?
0.
0. So we're going to do that x times x to get x squared. And how do I get a negative 4? Plus 2 and minus 2. Okay, now, in order for something to cancel, it's all multiplication. So we have x plus 2 times x plus 4 over 3 times x plus 4 times x plus 2 times x minus 2. Do you see that these x plus 2's cancel top to bottom? Do you see the x plus 4? Is there anything else that cancels?
No. It's just
0.
Right.
If you leave 3 and then x minus 2, you just got it wrong because where was that left?
On the bottom side.
And the denominator, so what's in the top?
1.
A 1. Okay, so you do have to pay attention to where it's left. I'm fine with you leaving the pieces. Someone else might have the answer as 3x minus 6 if they redistribute. I'm fine with this. All right, look at example C.
We're distributing.
We're actually not. I'm going to build this as a fraction, put it over 1, because it helps me to see the fraction. So my numerator is 2v minus 9 over just 1 times v plus 6. And then what's the GCF here? What number am I going to try first? I'm going to try 18 first. So what am I doing? 81? Does it divide by 18 evenly? Nope, it doesn't. So what's the GCF of these two? 9? But I'm going to try 18 first. So I'm left with 2v squared minus 9. Now, typically, I would be looking saying, can I factor this further? But that 2 there doesn't let me factor it further. So, do they have anything in common? No. So we're stuck, and this would be our answer. 2v minus 9 times v plus 6 over 1 times 9, and then 2v squared minus 9. So this problem, nothing's canceling, so this is our final answer. We just put all the pieces together. If this was a v squared here, then these two would cancel out, or vice versa if the square wasn't there. But they have to be the exact thing, and they are not to cancel. Okay, now, problem D. Again, this is multiplication, and we have 4 pieces to look at. 1, 2, 3, 4. There's a GCF here. We need to figure out what it is. So I'm looking at 28. 7 goes into 28. Does 7 go into 40? 2 goes in. What else goes in? You know how I said 7 goes into 28, but it doesn't go into 40?
Yeah.
7 times what's 28? 7 times 4. 4 is my factor. Now 14, but that doesn't work either. So I'm going to take out not just a 4, but a 4n squared. All right, what's left for my numerator? Wouldn't it be 7n plus 10? Are we good?
Here.
Okay, can my denominator factor? No, so 3n plus 2. And up here, this doesn't factor, but that's okay. What about this denominator? Does it factor? All right, they have a GCF you said of 5. So divide by 5. Be careful that you write down what's left. Okay, what do these have in common? Okay, so the 3n plus 2 can go as long as it's top to bottom. Yep. And then double check. You have a 4 times n squared and a 5. If the 4 and 5 reduce, we do that, but they don't. So what's left in the numerator? Over just 5. Now, again, we're not talking about the domain restrictions. We're just practicing breaking it down. All right, now if you flip it over, now we have a couple extra things. Like this has 3 pieces, but it's all multiplication. Now, in the other problem, I showed you let's cancel out the pieces and then do it. Let's just put this together. The top would be 1 times 1 times 20. How many x's do we have in the top? It would be because there's a 1 there and 7 there. All right, so x to the 8th. What do we have in the denominator? 30x to the 5th. Okay, look at your numbers. Yep, divide by 10 or knock out these zeros. So keep your fraction. I'm left with a 2 and a 3. All right, so who has more x's? You're saying the top? So take out 5, and what's left? Yep, there it is. That is your answer.
Beautiful, Miss Carney.
Thank you.
You're such a great teacher.
Wow, you're something else.
I love having you.
All right, 3B. Go ahead, take a minute. This is still multiplication, so factor all 4 pieces if possible. All right, so we took the GCF of 10 out of the top. The bottom was the easier factoring since A was 1. We chose to do a -4 and a -2, but you have to make sure your signs are right. X plus 3 stays in a GCF of 5. So I can cancel out the x plus 3. I can cancel out the x minus 4. Now there's one more thing that should reduce or cancel. That 10 and the 5. So 5 goes into 5 once, and it goes into here twice. So what's left in the numerator? 2. What's left in the denominator? X minus 2 times 1. You don't need the parentheses around the x minus 2. Okay, they're getting a little bit with bigger numbers here. So if you look at C, when I have this 16K and this 48, I'm going to try and see if 16 divides in both of them first. Does 16 divide into both of them? Well, get a calculator and see. I'm pretty sure I'm good. Does anybody agree with me?
Yeah.
All right. What comes out of the denominator? 2, and what's left? K plus? Okay. Still times. I'm going to try and see if 18 goes into 90, which I'm not thinking it does.
I don't even know.
Oh, it does. Okay. But you want to try, always try the biggest number because we want the GCF. Just K plus 5. It's 5. And then what comes out of the denominator? and a k. So k minus 3. All right, what do they have in common that will cancel?
K minus 3, k plus 5.
All right, is there anything else?
Factor out. You can do that 16 and 2 and then the 8 and 5.
Okay, now you can do any top to any bottom, but I would probably do what you're saying. 2 goes into 2 once, it goes into here 8. 18 and 10 both divide by 2, so a 9 and a 5. There's still one more thing that can cancel. Do you see your k's here?
Yeah, so it'll be 1k.
So I can only do this because it's multiplication. So 1k cancels and 1k cancels. All right, what's left in the top? 8 times 9 times k. What's left in the bottom? 1 times 5.
And why is it times k and then not set on the 9?
Because it's understood. It's 18 times k squared, so it's still 9. All this is multiplication. So we should have 72k over 5. Now, maybe you put this together, but I don't want to multiply the 16 times 18 because the number gets pretty big. So I'd like to cross cancel or reduce as we go. All right, 3D. GCF with 25 and 40. It's going to be 5. Hey, I just want to make sure we're real clear. You can't come in and cancel the 25x and 25x. Are we all understanding that? You cannot. Well, the problem is it looks really easy. You can't cancel over dish subtraction. It all has to be chunks of multiplication. All right, what's left? 5x minus 8. Stop it. All over, what's the common denominator or common factor here? Another 5. What's left?
5x minus 9.
All right, times. 35 doesn't go into 63, but what's the next big number that goes into 35? 7. So I'm leaving that, so that'd be 5x minus. All right, in the denominator? No GCF. All right, so what's going to cancel?
5x minus 8, 5x minus 9.
Anything else? Well, can't these 5s cancel?
Yes.
Okay, so this 5 can't cancel here because it's attached to the x minus 8. But these 5s can cancel. So what's left in the numerator?
7.
Just 7 or 7 over 1.
Do you have to put that 7 over 1?
Nope. But if it was in the numerator, you would need the 1 there. Okay, so 7 over 1's fine, but it's just 7.
All right, we're running out.